Caterpillar makes more types of construction and mining equipment than almost any other company on Earth. Bulldozers, excavators, motor graders, articulated trucks, haul trucks, scrapers, compactors, and wheel loaders, all of them ranging from the small machines that work on suburban construction sites to the giants that work in the world's largest mines. At the top of each product line sits a machine that represents Caterpillar's current statement about what is achievable in that category. The best they can build, the most capable, the largest. At the top of Caterpillar's wheel loader line sits the 994K. The 9994 designation has existed in Caterpillar's lineup for decades. The original 9994 was introduced in 1990. And subsequent variants have carried the same designation through continuous development. The K variant, the current production model, represents the accumulated engineering improvements of more than 3 decades of competitive development in the ultra-large wheel loader category. It is not a new machine in the sense of a clean sheet design. It is the current iteration of a design that has been progressively refined through field experience, competitive pressure, and technological advancement. This distinction matters. A machine that has been continuously developed over 30 years carries within it the lessons of tens of thousands of operating hours in dozens of mines across multiple continents. Every weakness found in the field has been addressed. Every operational feedback from experienced operators has been incorporated. Every competitive development from Komatsu, Liebherr, and other manufacturers has been responded to. The 994K is not just a big loader. It is a mature engineering system that has been tested, broken, fixed, and improved, and tested again on the largest scale that wheel loader applications provide. But before we get into the 994K's engineering, before the engine, before the hydraulics, before the powertrain, we need to talk about where it fits in the competitive landscape of ultra-large wheel loading. Because the 994K does not operate in a vacuum, it competes directly against the Le Tourneau L2350, the machine we discussed in Video 10, and that competition has shaped the 994K's development in ways that are not always visible in the specification comparison, but are deeply embedded in the engineering choices the machine reflects. The L2350 has a bucket capacity of 40 cubic meters and uses electric wheel drive. The 994K has a bucket capacity of approximately 41 cubic meters in its largest production configuration, essentially matching the L2350, and uses a mechanical powertrain. 2 machines of similar bucket capacity, similar operating weight, similar target applications, built on completely different drivetrain philosophies by manufacturers with completely different engineering cultures. The comparison is instructive, and the reason both machines exist and both sell successfully tells you something important about engineering trade-offs that headline specifications cannot convey. But that's not even the most interesting aspect of this competition. Because the choice between the 994K and the L2350 is not, for most minds, a choice between better and worse. It is a choice between different maintenance requirements, different performance characteristics in specific conditions, different operational economics depending on the specific application. And understanding those differences requires understanding each machine as a complete engineering system rather than as a collection of individual specifications. The Caterpillar 994K has an operating weight of approximately 234,000 kilograms in its standard configuration. This is somewhat lighter than the Le Tourneau L2350's 262,000 kilograms, reflecting the weight penalty of electric drive components. The lighter weight gives the 994K lower ground pressure, an advantage in mining areas where ground conditions are variable. The bucket capacity of the 994K reaches approximately 41 cubic meters in its high-capacity configuration, essentially matching the L2350. The maximum payload is approximately 72 to 80 metric tons, depending on material density and bucket configuration. This loading capacity allows the 994K to fill a Caterpillar 797F haul truck in just 5 passes. The 994K is powered by a Caterpillar C175-16 diesel engine, a 16-cylinder variant of the engine family used in the 797F. The C175-16 produces approximately 1,800 gross horsepower, applied through a mechanical powertrain rather than an electric generator. The powertrain is conventional, engine-to-torque converter to power shift transmission to front and rear axles. The torque converter provides torque multiplication at low speeds, providing high rim pull force for productive pile engagement. The planetary gear transmission allows the operator to select the appropriate gear for the current task. This mechanical powertrain produces a performance characteristic different from the L2350's electric drive, noticed immediately by experienced operators. The torque converter introduces some power loss, where mechanical slip dissipates power as heat during partial stall. The multiple mechanical components, transmission, axles, and wheel ends, each require regular maintenance attention. However, this powertrain is well understood by heavy equipment mechanics who maintain Caterpillar equipment worldwide. Service procedures are documented, and parts are readily available through Caterpillar's extensive dealer network. A mine maintaining a fleet of 797F haul trucks and D11 bulldozers can use the same technicians and parts infrastructure. This operational integration has a significant value in the total cost of ownership calculation. The hydraulic system controls the lift arms and bucket, scaled to the 994K's massive operating dimensions. The lift cylinders must support a bucket load of up to 80 metric tons through the full range of motion. The bucket cylinder must generate sufficient force to curl through a full pile and overcome the inertia of the payload. Thermal management systems are designed for sustained high-load operation in high ambient temperature mining environments. The 9994K uses articulated steering, where the machine bends in the middle to change direction. A larger articulation angle produces a tighter turn but requires more structural complexity at the joint. The articulation joint is one of the most highly loaded structural joints on the machine. When fully loaded and partway through a turn, the forces acting on this joint are complex and extreme. The joint must transmit these forces through millions of cycles without fatigue failure, reflecting decades of design refinement. Caterpillar's design choices for the 994K reflect a balance between turning radius and structural durability refined over decades. Operating a 994K productively, achieving the cycle times and payload consistency that justify the machine's capital cost, requires a combination of machine capability and operator skill that takes time to develop. The fundamental operating sequence, approach the pile, crowd the bucket in, fill, lift, carry to the truck, dump, return, is the same as any wheel loader. At the 994K's scale, the execution of each step requires judgments and skills specific to this machine class. The approach to the pile is the most skill-intensive part of the cycle. The operator must judge the pile's geometry, where the material is most accessible, where the pile face will yield most productively, and where obstacles might cause problems. Too shallow an approach, and the bucket skims across the surface. Too steep, and the machine encounters excessive resistance, loses momentum, and stalls. The correct approach angle is something experienced operators develop through hundreds of hours of operating the specific machine in specific material. The crowd into the pile, where the machine drives forward with the bucket at ground level, generates the highest rim pull forces in the cycle. This is where the powertrain is most heavily loaded, where the tires are most stressed, and where the articulation joint is under peak load. Managing this phase correctly, maintaining momentum without spinning tires, is the core skill of effective wheel loader operation. The lift and carry phase is mechanically demanding. Lifting 80 metric tons from ground level to truck dump height requires substantial hydraulic energy. The 994K's hydraulic system is sized to achieve productive lift speeds with full payloads, maintaining consistent lift times. The dump phase, positioning over the truck bed and releasing material, requires accurate positioning and controlled placement. Dumping too aggressively can damage truck liners. A skilled dump is a controlled release that places material evenly across the truck bed. The return phase is where cycle time can be unnecessarily extended by wide, inefficient arcs, rather than the most direct return path. Experienced operators minimize return time by planning each cycle's approach path during the previous cycle's return movement. These skills determine whether a 994K achieves 85% of its theoretical productivity or 95%. That difference represents substantial material. Caterpillar supports operators with training programs, both classroom-based and simulation-based, that compress the learning curve. The CAT simulator platform allows operators to practice in a virtual environment before working with the actual machine. What happened when Caterpillar first made simulation training available for 994K operators at a large copper mine in Chile was revealing. New operators who used simulation achieved productive cycle times significantly faster than those who went directly to machine operation. The simulation gave them a mental model, how it responds to inputs, how the material flows, allowing them to develop technique faster. The competition between the Caterpillar 994K and the Le Tourneau L2350 is one of the most closely watched competitive dynamics in large mining equipment. Both machines compete for the same customers at many of the same mines. Both have loyal user bases with strong opinions about which is superior. And both continue to be commercially successful despite the availability of the other. The fundamental difference lies in their powertrains. Mechanical powertrain versus electric wheel drive produces different performance profiles. The L235's electric drive provides superior traction control in loose or wet conditions. Its independent wheel motor control prevents wheel spin more effectively than the 994K's mechanical differential systems. In loading areas with variable ground conditions, the L235's traction advantage translates into fewer wheel spin events and more consistent rim pull. The 994K's mechanical powertrain provides advantages in areas where Caterpillar's engineering culture and dealer network create value. The parts availability through Caterpillar's global dealer network is unmatched by any other mining equipment manufacturer. The diagnostic and service tooling for Caterpillar mechanical components is standardized and widely available across the globe. For operations that run large Caterpillar fleets, the maintenance integration reduces the total operational complexity of fleet management. Neither machine dominates the market. The choice depends on specific application conditions and the existing maintenance infrastructure. Mining procurement teams conduct detailed total cost of ownership analysis before committing to equipment acquisitions of this scale. Over the 30-plus years since these machines appeared, this competitive dynamic has produced continuous improvement in both. Competition forces improvement. The L2350's electric drive innovation pushed Caterpillar to develop better traction control. In turn, CAT's advantages pushed competitors to improve their service infrastructure. Both machines are better today because the other exists. This is how competitive markets work, forcing both to continuously address their weaknesses. Mining operations benefit from decades of competitive pressure that has produced two genuinely excellent machines at the top of the wheel loader category. The Caterpillar 994K represents the current endpoint of a development trajectory that began with the original 994 in 1990. More than 30 years of field experience, competitive pressure, and technological advancement are embedded in the current machine's design. The structural improvements that addressed fatigue failures identified in early variants. The hydraulic improvements that improved cycle times and reduced fuel consumption. The electronic control improvements that made the machine easier to operate and maintain. The powertrain improvements that reduced maintenance requirements and extended component life. All of these improvements are present in the 994K, accumulated through continuous development rather than introduced in a single redesign. The development path forward for the 994K will follow the same industry-wide trends that are shaping every machine in this series. Autonomous operation is an active development focus, allowing the machine to navigate and load without an onboard operator. Caterpillar is developing the sensor, perception, and control systems needed for autonomous operation in complex mine-loading areas. Electrification, the transition to battery electric or fuel cell powertrains, is a longer horizon development for the 994K. The duty cycle of a continuously operating wheel loader creates higher energy demands than the intermittent operation of a haul truck. Caterpillar has committed to developing zero-emission large equipment. The 994K will eventually follow the industry toward electrification. Its mechanical powertrain will give way to an electric system that eliminates transmission losses, the current design's primary efficiency limitation. When that transition happens, the 994K and the L2350 will converge in their fundamental drive architecture. Both will be electric. The differentiation will shift to structural design, control system sophistication, and the accumulated operational knowledge of each company. The CAT 994K feeds the giants of open-pit mining. It fills the trucks that move the ore. It is the loading step that determines how fast material moves through the system, and at the top of the line, it does that job perfectly. Next, we move to another Japanese giant, the Komatsu PC8000, an 800-ton class hydraulic backhoe excavator that brings Komatsu's engineering philosophy to the top of the excavator category. A machine that competes directly with the Hitachi X8000, the Liebherr R9800, and the Bucyrus RH400 in the world's most demanding applications. The numbers are significant. The competitive context is fascinating. And we are just getting started.